Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. Before starting today's session, we will just revise what we learned in the previous session. In the previous session, we learned about the cell reactions during recharging of lead accumulator. Before that, we have studied cell reaction during discharging of the lead accumulator. That means we learned about the secondary voltaic cell, that is lead accumulator. What is secondary voltaic cell? The one which can be recharged, and then again and again we can use it by recharging. Lead accumulator is a typical cell which is used in automobiles, or we call it inverters. Today also we are going to learn about secondary dry cells. There are two secondary dry cells included in our syllabus. The first one is nickel cadmium storage cell, or it is also called NICAD storage cell, short form of nickel and cadmium. One more secondary dry cell we are going to study is a mercury battery. Both are secondary cells, that means they can be used by recharging, and they are dry cells also, because the electrolyte or the reactants which are generated are all in solid state. Hence, these two cells are called as secondary dry cells. So, let us begin today's session, and we will learn first secondary dry cell, that is a nickel cadmium storage cell, or it is also called NICAD storage cell. As I told you, nickel cadmium cell is secondary dry cell, the meaning of which you know very well. Secondary, the one which can be recharged; dry, the one which contains all the reactants in solid state. It is again told here, in other words, it is a dry cell that can be recharged. We learned one dry cell, which is primary voltaic cell, which cannot be recharged. That primary dry cell, it is a Leclanche cell, or we call it dry cell only. But this one particularly, nickel cadmium cell, is a secondary dry cell. Now, as usual, we will learn about the construction of the cell. In your syllabus, the figures or diagrams of both these cells are not included. Then you have to imagine the construction of the cell. But in the exam also, you will be asked to explain and not to draw. Hence, we will just learn about the construction of the cell, that is theoretical part. Construction of any cell requires what? Three basic things are required to construct a cell. One is anode, another is cathode, and third one is electrolyte. The reactions are going to take place around these electrodes and in the electrolytic cell. So, in NICAD cell, anode is a cadmium metal. Anode of the NICAD storage cell is cadmium metal, pure cadmium metal. Strip or rod is used as anode, and the cathode is nickel oxide, that is NiO2, which is supported on nickel. That means on the nickel strip, nickel oxide is coated, that is cathode. And third thing, what we require is electrolyte. The electrolyte solution is basic. Any basic solution is used. The one which gives us OH minus ions is basic solution. So three things we learned: anode, cathode, and electrolyte. Now, this is all about construction. Now, cell reactions. The electrode reactions that take place at anode, cathode, and overall cell reaction, in which we know at anode there is always oxidation. And here we are using cadmium as anode. So cadmium will give out electrons which come through external circuit towards cathode, where nickel oxide on nickel will accept those electrons and will be reduced. As usual, this construction or the circuit will be complete. So at anode what happens? But some complications or situations are there. What are those? That means we are using a basic solution as an electrolyte. When cadmium gets converted into positive ions, the OH minus ions from the reaction will react with that, and some complicated reactions will occur inside the cell. What are those? We will see in detail. And you also have to learn them while writing the correct reactions when asked in exam. Okay, so let us begin with what happens at anode. At anode, the reaction will be like this. This is anodic oxidation. That means cadmium is anode. It actually gives Cd plus 2 ions with 2 electrons. But in the medium, the electrolyte solution is basic. That means it provides OH minus ions. So, cadmium reacts with those OH minus ions to form cadmium hydroxide. And 2 electrons are released. The reaction will be like this, which occurs inside the cell. Now, these 2 electrons through external circuit travel towards cathode. What is cathode? Cathode is nickel oxide. So, at cathode, a reduction occurs and the reaction takes place like this. NiO2 is cathode. It accepts those electrons in presence of water because we are using solution. So, it contains water. So, NiO2, nickel oxide, accept those electrons in presence of water molecules and forms nickel hydroxide in solid state with the release of hydroxide ions again. Hence, the cathodic reduction reaction will be like this. NiO2 plus twice H2O plus 2 electrons gives NiOH twice plus 2 OH minus. When ions are released, the condition is always aqueous. And these are precipitates and they are in solid state. Now, overall cell reaction is summation of these two cells. So, what will be the overall cell reaction? We will add left to the left and right to the right, and the common species will be deleted. Now, 2 electrons to 2 electrons will be cancelled, like that 2H minus 2H minus will be cancelled. Hence, what remains to the left side is Cd in solid state plus NiO2 in solid state plus 2H2O, which is liquid, gives CdOH twice solid plus NiOH twice solid. This is overall cell reaction. As you see, both the products produced here are in solid state. Hence, this is called dry cell. Now, the reaction product at each electrode is solid that adheres to the electrode surface. Adheres, that gets attached, that gets coated on that metal, on that electrode, and hence nickel hydroxide and cadmium hydroxide will get attached on anode and cathode. Therefore, the cell can be easily recharged. This cell gives potential of about 1.4 volt. It is very important. Always remember the potential obtained from each and every cell. The cell has longer life than other dry cells. It has a longer life because it can be recharged again and again we can use. Hence, it has longer life than other dry cells. And what is the application of this cell? This cell is used in electronic watches, calculators, photographic equipments, etc. As this is a dry cell, first advantage of NICAD cell is it is a dry cell. So easily can be carried from one place to another. And another thing is it can be recharged. And hence it is very popular nowadays. So this is all about nickel cadmium storage cell. Understood? So what we learn basically here, the construction in which you have to describe the cell and the cell reaction in which you have to write anodic oxidation, cathodic reduction and overall cell reaction. So this is all about nickel cadmium cell. One more dry cell is included in your syllabus and that is Mercury Battery. As the name suggests, mercury is used in this cell, and this is again a secondary dry cell. Secondary dry cell, that means again it can be recharged, and products in the cell are also dry state. So it has, the mercury battery has zinc anode amalgamated with mercury. Any metal with mercury is called its amalgam. That means if it is sodium with Hg, then NaHg, it is written like this, Na-Hg, and it is called sodium amalgam. Like that, zinc along with Hg is called zinc amalgam. So we are using zinc amalgam as anode. That means zinc Hg combo. So it is used as anode. And then what is cathode? The cathode is a paste of mercury and carbon. As carbon is non-metal, so it is not called amalgam of carbon, but it is the combination of mercury and carbon. Understood about anode and cathode? Then again the third question, what will be the electrolyte? The electrolyte here is a strongly alkaline solution, and actually it is in paste condition. So strongly alkaline paste of potassium hydroxide and zinc oxide. KOH is strong alkali. So zinc oxide along with potassium hydroxide is used as an electrolyte. So this is all about construction. So as I told you, always remember these three things are very important. What is anode, what is cathode, and what is electrolyte, because all the reactions are going on against anode, cathode, and electrolyte. So these are important. Now the next thing is reactions, cell reactions or electrode reactions along with net cell reaction. As usual, at anode there will be oxidation, at cathode there will be reduction. So first reaction, what is anode here? Zinc amalgam. So ZnHg is zinc amalgam along with the electrolytic OH minus. We are using KOH, which is a strong electrolyte, and in liquid state it easily gets dissociated as K plus and OH minus ions. Those OH minus ions will react with zinc amalgam to give zinc oxide H2O plus 2 electrons. This is anodic oxidation. Now, what is cathode? Cathode is mercury and carbon. Here, that mercury will form mercurous oxide. This HgO will react, or in presence of water, accept those electrons coming from anode and get converted into mercury plus 2H minus ions. That means electrons are released which come towards cathode where HgO is there, which accept those electrons in presence of water to give mercury along with the release of 2H minus ions. As these are ions, it is written aqueous in the bracket. Always remember this thing. Wherever the ions come, the species with charge is called ions, and in bracket you should write aqueous. When H2O comes, write in bracket liquid. When other things are there, then you have to remember this. Some are in solid state, some are in liquid state. Those things you have to remember. And it is necessary, it is compulsory to write the states of all the reaction products in the reaction. So this is cathodic reduction. Understood? Then what is overall cell reaction? It is the summation of these two reactions. So this is overall cell reaction. The common thing, that is 2H minus will be cancelled, 2 electrons will be cancelled. What remains here? H2O liquid also will be cancelled. What remains here is zinc amalgam plus HgO gives ZnO plus mercury. As you see, mercury is also semi-solid. In semi-solid state, it is written liquid here. But all other things are in solid state, and mercury is not totally liquid. It is a thick liquid, or it is somewhat semi-solid, semi-liquid state. Hence, the product here are in a solid state. As these are in solid state, it is again a dry cell. So these are the reactions. These are very important. You have to remember, And the best way to remember the reactions is write down again and again. Just you can write down by just copy down those first time, then again see it and write down. But try to remember that and write down without observing, without copying it. Then only you will get confidence that you can write it in exam. Understood? Now, the cell reactions or overall reaction involves only solid substances, and there is no change in electrolyte composition during operation. During operation, the electrolyte, that is ZNO, remains as it is. HGO is there. That means KOH, as it is used and again restored, there is no change in the electrolyte composition during operation. The mercury battery therefore provides more constant voltage because there is no much change in the electrolyte composition. It will be restored again and again. And that is the important thing. Anode and cathode is there. Electrolyte solution, if it regains, it is restored, that means it provides more constant voltage than Leclanche dry cell. And the voltage obtained here is 1.35 volt. Remember this figure also. So, one more thing is beneficial of this mercury is that it also has considerable higher capacity and longer life than dry cell. So, dry cell, it is much better than a dry cell. In previous times, we were using dry cell in most of our electronic equipments, but nowadays, NICAD cell and mercury battery are more popular. So, because the reason is this, they have considerably higher capacity and a longer life. The mercury dry cell finds use in hearing aids, electric watches, and pacemakers. So, because of the longer life and more beneficial, it is more beneficial. Hence, nowadays it is used in hearing aids, electric watches, and pacemakers. So, this is all about mercury battery and all about today's session. In the next session, we are going to learn about fuel cells. But as I told you earlier also, this year 25% of the syllabus has been reduced for this year only, in which lead accumulator cell or lead battery, storage battery, that is also not included, or that is also not for this exam, but it will be there in the CET or JE exam. In that way, fuel cells are also deleted from the syllabus for this year. But we will learn about it because it is there for CET. Understood? So, in the next session, we'll learn about fuel cells. For today, we will stop here. Now, time for assignment. Write the electrode reactions and net cell reaction in both the cells we learned today. Both are dry cells. That is, first one is NICAD battery and second is mercury cell. So write down the reactions by keeping your textbooks open in front of you. Thank you.